Hello, welcome. I'm Bill Wake. We're here working on basically algorithm visualization. We've been doing it in the context of this Towers of Hanoi problem. Um, Mostly that's an excuse to get a stack going and a visualization of it and a counter and so on. And so today we'll do a little bit of wrap up on kind of making the counter work, which was working at one point and stopped after we changed something around, and some packaging and just sort of lessons learned, trying to kind of get ready to do the next one and have some more pieces there to go with. All right, so let's go to the IDE. All right, I kicked off tests. They're not done, but that's okay. So let's see. We had a couple things left over. One was we never made the app able to rerun, so you run it once and you're done. And it'd be nice if it worked again. I don't think that's the most important thing. I think this thread issue is more important. Are we updating the counter only when the stack changes? We should update it every time the counter changes. And now it's like, why isn't the counter even updating? So let's put that on top. It seems to be updating on my Chiron. All right. So I've got a theory of what's going wrong there, but we'll see what's up. And then I want to add something that's more like packaging. And let's move this one up. Okay. So packaging, I want to capture some lessons learned, or at least a theory of our approach, and maybe some actual, physical packaging. Like, I never made Swift packages before that were meant to be plugged into a different project. It'd be nice to start carrying something forward from that. Let's see, what else to have in mind? Another one is animation. We've got these objects like on our stack, and it just sort of appears randomly-ish between the stacks. It would be nice if it would be nice if we could see them moving. I don't know how hard that'll be. All right, so our tests passed. That's good. All right, let's look at this counter thing. So we'll run. And if we don't get to all this stuff today, I'm not surprised. Let's see what I need to carry forward. We won't use Hanoi as our project going forward. So a little bit about lessons learned in packaging is probably the critical thing. So we'll make sure we leave time for that. Maybe we'll catch some of those things now. While that starts up, let me just add a page and let's go to it. I guess bullets will do it. This is our visualization approach. Okay. And one thing we know we're doing is the algorithm to visualize is run in a separate thread, global. Okay. The components we want to view must be updated in the main thread. And so kind of a consequence of that is any modifier method, I'll call it that, anything that changes the state, maybe that would be a better way to say that, any method that changes the state must run in main thread. Okay, that's kind of the consequence. I guess there's another step in here. Components to view will be observable object. Okay, and fields to view will be at published. Okay, We there yet? All right. So here we've got the Hanoi stack, Towers of Hanoi stack. Number of calls 0. I hit go. It should start moving the stack around, and it should update the number of calls. Okay, so here it's moving the stack, but it still says number of calls 0. And that, good. Okay. Let's see. So let's close everything else. Okay, so here's our counter. It does run in the main thread. That's good. Let's find the view. Let's see. So number of calls. So that's this object. All right. So what I think we've wanted to say is this should be an observable object. Observable object. And this should be published. Okay. Let's compare that to the tower object. Oh, that's the app. Okay, where's the tower? Yeah, we said it was published here, but the counter itself is what's modified. So I think that's the thing that needs to be this way. Tower is observable object. Okay, an observable object means if you mark a field published, before you change the field, the UI system will get a notification that this field is going to change. And so it can use that to kind of like mark parts of the screen as dirty or, will need to be changed. And when it updates, it only needs to compare or modify the parts that were marked as ready to change. All right, let's see if this works. And I have no good way to test all this stuff. I wish there were. Yeah, I don't think I have any way that I can do useful UI tests. I mean, so much of it is like get it in the right thread, mark it with the right meta thing. All right, let's see if we're making any progress here. So peg 1, 2, number of calls is still not updating. Why is that? Okay, and let's compare these. So class counter observable object has a published field. It runs in the main thread. Now what I'm dreading is at least in one of the other projects I did, I ended up having to, like, subordinate objects that update had to kind of pass their update along manually, which was really annoying to me. I don't know if that's what's going on here. Let's see if we can check out the content view. And maybe the deal is we haven't, I don't know if we can, I'd almost like to do this. Something like that. I don't think it'll let me update one field from another, though. Yeah. Well, we can pass it in, and that might be... I need some sort of wall chart that I can plaster on my wall to remind me of all these differences between how do you binding versus state object and all this stuff. Binding example Swift UI. Let's try that. And they keep changing it, so that makes it hard in a sense that the things the examples people give are sometimes not useful anymore. Okay, binding var person of person. I think person is not. Yeah, person is just a struct. Person store is observable object. Binding of a value must be a value type. Yes, okay. So we need observed object. At published. That's in our observable. Okay, and so we know this doesn't work. All right, what I can do is the app. I think I can pass the object I want. Let me go back down here. Did I use observed down here? Stack view. Observed. Yeah, I think that's the thing we're after. So I'm going to make this observed. That. And now my app can pass that in. All right. So I'm refactoring this to work from the object passed in at the top level. Let me make sure that works. I have to say it, or appears to work. Yeah. Put a different one in our preview just to see how it goes. And so the preview is nice in a way. You can put multiple ones. You could show I think you can show different orientations or different, renderings for different things. Okay, so this should act as it did before. Number of calls not being updated, but the stack is updated. Okay. Number of calls is not being there. I'd like to see. I was hoping it would update at the end even, because that would say something was not right. But all right, let's try our app again. Okay, so I think what I can do. Why their templates aren't tabbed right? I've never understood why that would be. All right, tower. All right, let me see if this works. So, way I understand it, you have observable object says I'm a publisher. When you look at my fields and I'm going to update them, I will notify you. And then you can also have structs, and then a struct you can attach with at state. You can create it in the view, or at binding, somebody else is creating it for you. And so if you were calling a subview, you would pass it as a binding. And if you were, at the top level, you don't have to. Then observable object is for these actual objects, not structs, that are observables. So observed object says I want to be notified if that thing changes. All right. Did I not click go? You always have that pause because it's working its way down. Okay, but that did not update. All right, so this is okay, and then I'd like to add the counter as a separate thing. Okay, and we can pass that in as well from here. And the counter is tower.count number of calls. Okay, and then the content view needs the same thing. We'll have to extract it the same way, I guess. Okay. Still not happy. Instance member. Oh. Well, that sounds interesting. All right. My hope at this point is we have an observed object on the counter field, and we should be updating. Hey, 3, 4. Yeah, it takes you a few calls to get down there, and then it works. It starts moving. So that pause we had at first was going down level 1, 2, 3, 4. Now move 1, and then they move from there. And number of calls 15 is right. It's 2 to the nth minus 1. 2 to the 4th minus 1 is 15. Okay. Yeah, this article caught my eye because we do have things we want to do. Coordinate. Combine latest. I don't know. I went through Daniel Steinberg's book on combine, and it all made sense, but I haven't been using it, so it's kind of less clear to me. I think what we're saying here the zip operator delivers values only when all the publishers emit. Okay, so you combine these 3 and you check that they all satisfy the current fields. Yeah. Okay, well, that's interesting. The other thing I have that goes on is most of the examples you see, like observable object, it's got a bunch of primitive fields and not other objects. And I think my challenge is maybe the framework is designed to work better with that and doesn't particularly like you wrapping things up into objects. I don't know. That seems to be what happens. So I'm learning a little bit at a time. All right. So I think what we've done is we got the counter updating, and yeah, let's just say make counter an observable object. Okay, and that is That was under the threads issue. Okay, make the counter an observable object. Are we updating the counter every time? Only when the stack changes. We should update it every time the counter changes. I think it did that. Let's see if we can see it. We should see every number 0 to 15. And I know we weren't seeing that. At least sometimes it seemed like the numbers were updating when the stack changed, but not when the counter changed. All right, so 1, 2. I won't say them. It's tempting. But it's pretty clear we're okay. All right. Now there's a little bouncing vertically. I'm not so fond of that, but I'm sure we could get rid of it. This updates every time the counter changes. Okay, so that dealt with the threads issue. That is good. Okay. Let's finish this notion of lessons learned. That's under packaging. Okay, so what do we got going on here? The algorithm to visualize is run a separate thread. Let's see how that happens. It's in the content view. It's triggered up here. Okay, so here's some example code. Yeah, can I? Okay, so that's the code that makes that happen. Components must be updated in the main thread. Let's put a call in there. Here's a component. So it does something like that. Well, this feels like comes before that, doesn't it? Components to view will be observable object. Fields to view will be at published. That seems sensible. Maybe we want to say any. Let's combine this. Any. Well, let's keep this part. I think that's redundant to it. Okay. The other thing we did was we created a view component to display our, I don't know, can I call them data structures? Maybe that's the right kind of thing. Okay. AG stack view. All right. Well, I don't know if I need to say more than that. Let's see how that looks. Okay, so the algorithm is run a separate thread. Dispatch global. Components to view. Maybe I should say data structures to view will be observable object. Just to keep my language consistent. Data structures will be observable object. Fields will be published. Any method that changes the state must run in the main thread. Create a view component to display our data structures. Right. Make the main algorithm sleep. To slow it enough to view. If that makes sense. And we had some code for that. That's in tower. And that's here. Whoops. Copy that. Yeah. Okay. Yeah. Now I don't think we have the ideal. Well, let's take another situation where we would like to step through our algorithm. And maybe there's critical steps or something, but like there's a handoff of control to do a step, right? If you're in a debugger, you tell the debugger step and it goes off and it runs one line or one part of an expression or something like that. And then it comes back to the debugger and you can say step again. We can't do that with the way we are here. We're just saying in the main loop. So there's not a main loop per se with this because the whole thing's a big recursive thing, right? Everything's a move or base case. But our main thing that gets called recursively over and over and over is this move function. And so we put the delay at the top of that function. Now, if we had multiple places we wanted to see, then we would have to be, we'd have to put delays in multiple places. But really, it's like, yeah, if I wanted to imagine like somehow turning the algorithm inside out in a way that as it tried to do a next step, that we got control at our visualizer level rather than a debugger. We're not a debugger, we're a visualizer. I would love to have a button that just says, I don't know, it's going to wait for input or something, It's like my step button, and I can either say step, 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 or I can just tell it go. I mean, that's a very common debugger thing. I'd like the same kind of thing in my simulator. But that means at the point where I have a sleep here, I need to make a decision about whether to pause or not, or how long to pause. So I'm keeping that. I think I'll keep that as an open issue in my gradual move towards algorithm visualizations. What I want to do is I'm making these videos rather than the last couple of times I've tackled a pretty big problem. I did my sort tables grid visualization, and then I did kind of the heart of an Elm interpreter. And the first one was over 100 episodes, and the second was 50 or 51, I think. I'm trying to do more short form kind of things, where short is like a week's worth of videos. So last week it was really about recursion with a little bit of algorithm visualization thrown in. This week it's keeping the same example, recursive Towers of Hanoi, but we're throwing in more visualization stuff and trying to understand, I'd love to just take an algorithm, mindlessly apply a few changes, and have a visualization, have it plugged into my framework or something. But like this thing here, something has got to be, it has to pause. And I don't know, again, this is this multi-threaded thing. Like I'm imagining there's some sort of UI button that says, pause or, single step or just go. And rather than use sleep, it probably needs to be like, wait until the visualizer says, go to the next step. it's like wait here, and it just pauses indefinitely until somebody hits step or go. And if it's go, then it doesn't wait when it gets there. So that's going to be a challenge. What it's going to mean is I've got to have something on my UI thread that changes. I mean, there's got to be something that the main algorithm is observing to decide whether or not to keep moving or stop. And if it's stop, it's kind of like pause until something changes, and the UI is going to change that. So I don't know, maybe there's an experiment in there. And, I think I'm going to do a little visualization on every algorithm I work on for a little while I'm engaged with these algorithms. What I envision is as I do them, I'll need new data structures. Like we're going to probably do Dijkstra's shunt yard algorithm next week. And I know I need a stream and maybe a queue. Maybe it's just a queue. I don't know, but a stream and or a queue and a stack. Well, I've got a stack. It does things. I've got a counter. It does things. Eventually I'll have a stack and a queue and probably a set and a counter and maybe some, little boxes that just show you interesting things about the algorithm that, let you know what the thing is doing. Once I've got those components, those are the heart of most algorithms that I would look at. And I get fascinated by the parsing algorithms, and I don't know how much I want to how much I want to do with that. I mean, we'll do some, and there's all kinds of other algorithms out there that are interesting. So, the sort of classic data structure kind of ones, that's fine, that'll work. Let's see. So, okay, so I'm happy with where we are. So let's commit. And what we did was we made the counter update as the towers move. All right. Put to-do out here. Okay. So lessons learned. I think that's what we've been doing here. Let's make a little thing for packaging down here. Oops, and that's in Keynote. Okay. And well, it's probably a good time for a break. Well, let's take a break, and then I think we'll come back and see if we can do some animation. I want to lean on the built-in Swift UI animation, but I think like when you put something on the stack and we say the number is its own identifier, it sort of knows where that number is, and I think it should be able to visualize that somehow. I don't know what that means exactly, but we'll find out. So see you in 2 or 3 minutes. Welcome back. Okay, so some animation, and again, I'm just gonna use the old internet. Okay, so you got animations you can specify on the thing, used on bindings. When you're working with a regular state rather than bindings, you can animate with by animation. Okay, we are working with, I guess, I don't know, is that a regular state rather than bindings? Animation modifier. Okay, they got a list of rows. Yep. I assume they're going to say animation somewhere. Animation spring. Well, this is a learning opportunity, as they say. I don't know if I can put it on here. Let's find. Well, animation. Okay, that must be the thing with string. Spring. No. Well, ease in out. Do I have to say something? I probably do, right? Well, let's try spring. Persistent spring. Mixed with other springs, each animation will be replaced by its successor, preserving velocity. I don't know. Member spring. Okay. So this is on our towers. Let's see what happens. I don't know if we'll be able to see anything or not. I mean, I'd like something to animate. I would like to get these things inside animating, but I don't see how it can know that. Okay, it takes a few. Oh. Well, that's something. I don't think it's animating those individual objects. Let's see the stack view. And the real thing is I want each object to, I would love it to move between the stacks. I mean, I would really love for the 4 to bounce, or the 1 to visually, you know, jump over to the next stack. I don't think that's what I'm getting. Let's put it on the end here. Animation spring. Dot spring. I mean, it definitely did something to the view. It smooths out the transitions, but I think I've got to do some work to get this thing at a fixed position to the bottom, and I'm not quite sure how that goes. Yeah, you can see it's fading out. Yeah. I mean, it's something. Okay. I'll keep that. It's pretty minimal. What else we got? I don't think the number of calls matters. Let's see if we can figure out the positioning. I know there's like a fixed. Let's see. Swift UI force fixed view size. We're ending up with my G site here. Okay, the fixed size modifier fixes the view at its ideal size. That's the frame. Okay, if I put it on fixed size and a frame, well, it's not quite what I... Maybe the frame is enough. I think the owning view should make that decision, though. So the stack view, this, I'm going to say frame, and I don't know how to even interpret these sizes. Oh, I should be using my preview. We'll do that next time, if I remember. Yeah, something's weird. And maybe it's even better to do it in here because it shows you outlines of where the views are and stuff like that. I think there's a way to hide that. Well, I know I can do it that way. Okay, there's my 100 by 100, and that's why it's all chopped off, I think. Let's make it 300. Stop. What happened? It's catching up. Okay, I guess maybe 300 is plenty there too. That doesn't look square to me, but so I'm trying to put the box that holds it in the center, but I don't know if I have the bottoms of the stacks tied together. No, they're bouncing around still. Okay, but maybe that's the fixed size thing. Fixed size, horizontal and vertical, I think is what I want. Okay, here we let the view expand horizontally. This level of control. Oh, axis of expansion. So that probably should be false, false. Okay. And we can tell after the first move, right? Yep. Bloop. Okay. No. Well, the width should probably be infinity. Okay, we don't care about the size, the width. We do want the height to be there, aligned to the center. So we want the box in the middle is basically it. That's the H stack. You know, Am I putting this on the wrong thing? Height 300. Why is it that height now? No. Alignment bottom. That seems to be the thing that should make them. Well, we'll see what we can do in here. They should all be the same height. That definitely worries me. But I think what's going on is I'm only applying it to the whole stack. H stack is the horizontal stack of these three things. What is your purple message? Invalid frame dimension. Okay. Didn't like my infinity theory. Thought I was doing the right thing. Okay. So align the tower pegs, the towers at their bottom. That is happening here, which we liked. I've got the whole thing framed. I don't know if I can. Yeah, I can touch the different pieces. So there's the H stack in its giant frame. Now, why this? Let me take off this padding and see what happens. Invalid frame dimension. Negative or non-finite? Are you updating? I can't see that that's making any difference. Well, maybe I need to look up the Swift UI version of this. Fixed size. View proposes a size to each child. If the child doesn't need a fixed size, it can conform to the size offered by the parent. Maintains its child's ideal size in both dimensions. So let's take off this stuff. I guess we can't tell the dynamics of the situation with the preview, unfortunately. Can result in the view exceeding the parent's bounds. Fixed size creates a counter proposal. Says the view depends on the view and how you've configured it. Fixes this at its ideal size in the specified dimensions. I don't think we've done anything that would improve the situation. Yeah, there it goes. Well, the frame seems okay. And that's telling it. All right, so sorry, bear with me. So I've got a horizontal stack aligned at the bottom. That's these three things. When they're running, they stay aligned at the bottom all right, but they vary as the height of this stack, each stack changes. Well, as the maximum height of the stacks changes, this thing is bouncing up and down. Okay, so when they're spread evenly, it's pretty short, and then it gets tall like this, and the baseline moves. The go seems to stay where it belongs. I wonder if I take this out, what do I see? I have a feeling it's not making any impact. Well, let's not make it so big. Let's say your width is 100. Your height is 300. I'm going to take this one out and just rely on this. Now we've lost our alignment to the bottom. Why? But are you consistent? Yeah, it's consistent, but it's consistently in the middle. All right, let's see if a preview shows us anything different. I mean, because we can get in here and see what component is tied to what. Okay, there's a stack view. Alignment center. Oh, well, maybe that should be bottom. Now we're talking. Okay, let's. And I think, yeah. Ha. Nice, nice, nice. Okay, we can make things a little tighter, I think. But it's not bad. I mean, the 100 seems to be working pretty well for it. So let's make this like 75. 300 is probably okay. We don't seem to need it down here. And we'll run. So I think we're telling each stack view, you must be at the bottom of your view to be useful. I mean, that's your goal. And we could do 8, which would probably take forever to run, but we got room for it. 75 puts them a little closer together. I'm happy. Okay. So what we've done is, I guess we added animation, minor animation, and we made it so bottom of all stacks is consistent. We fixed. Okay, now the stuff on our stack. I have a feeling. Let's play with it a little bit here. We're pushing each size, but I bet there's a repeat or something like that. I want to make some discs just for my amusement. I'm pretty sure there's a constructor that will let me repeat stuff. Repeating string count in. $0 string of that. Oh, he's putting numbers. Stack. I'm going to make these strings. It's a pity I have 3 of them. Actually, I don't think anybody looks at stack A, B, or C, peg A. Is everybody going to work? Well, let's give it a go. Um. All right. Well, let's put a box in here if we can. Square. Let's just use that thing. And content view. Let's see how that works. Still not quite enough. Okay. It would be nice. Okay, let's see what we can do. That's about as that's about as wide as it can be, I think. And that is definitely not the same width between it. Well, it's exceeding its thing. I guess that's the problem. I know I can set a font size somewhere. Font size. Yeah, I can set a font. Oh, thank you. I think there's a bunch of defaults, right? Yeah. I don't know if body is the default. But let's try it. I don't know if you can put it on here. Or if we have to put it down at the stack level. I think there's a small, well, there's caption. Well, that didn't seem to change anything. Of course, that one's probably the default. Footnote, maybe that's gotta be smaller, right? I don't know if it bubbles down into the inner thing. Okay. That's almost acceptable. It's looking like a real Towers of Hanoi program, isn't it? Huh. Okay. What was the answer people gave? Nope. This kind of thing might be interesting. He's apparently too big. Let's try 10. I'm just glad I can do it from the outside. It's always hard to know the balance of how much you want to push into your default display object. Okay, it's a little wide. You can see the bar is still over there. But Yeah. So its width does adjust as the things go in. But I call that pretty good. Those brackets may be annoying. It would be nice. Where's that overlay thing? Can we do that at the upper level? Stack view. I'm going to try and put it on the H stack. Divider color background red alignment bottom. If it goes all the way across, I think that's all right. It might even be better. Okay, can I resume? Oh. My width is too wide. But I can't see. It looks like it's there. So I think when the other blocks are gone, we'll see it. Okay, I've shrunk the size, so it's off, but I think I like it this way. Those stacks are a little more grounded. I could try putting it on each one. Maybe that would be an improvement. Let's try that. Again, I don't know that I can see it. Oh, it doesn't work there. Isn't that so weird? You say bottom and it says, oh, you must mean right down the middle. I mean, it's annoying. Okay. Let's trim this down a little bit more. I don't know if we can get this to a... Let's even try it pretty small. Did I not delete that? I did not. I feel like this startup time is oddly slow, but... And, you know, I think I can take that bracket out of there now, right? I mean, it's got... Well... Yeah, let's take the bracket out. I think that's a bug. I don't know. I'm gonna leave it for future reference, I guess. We'll see. I'm still kind of feeling my way through on this stuff. Yeah, the chaining width is a touch weird, but I'm okay. Yeah. All right. Let's take a break again, 2 or 3 minutes, I think the work I'm going to do when we come back is start figuring out how to package this up. It should be. I mean, I feel like my stack view and my counter should be in some sort of folder, or at least move them to a folder, and then probably some sort of library kind of thing. So we'll see what we can do. But 2 or 3 minutes, come back and tackle that. All right, see you. Welcome back. Okay, so let's see. So where we want to go. Like right now, my stuff is spread around. I have a counter as a data structure, a stack as a data structure, and then I have a stack view, and then I have this as a little helper method, the thread, and the tower is the algorithm I want to visualize. Excuse me. I want to make some sort of library that is going to have the counter, the stack, the thread thing, and the stack view. And then I want to expand that with, queue and list and set and whatever else comes up. Okay, so, and I've never packaged a library with Swift. Package a library. I don't know what you do. Create a library using Swift Package Manager. So you're going to watch me read. Okay, libraries and frameworks and modules and bundles. Okay. A module is a code distribution. Okay. Has a namespace. All right. iOS bundles ship related files in one package. Can access bundle resources without knowing the internal structure. The library is a collection of resources and code. Well, a library sounds like what we're doing. Source files. Some sort of library, I guess. Dynamic library, not copied. Can include resources. Allow one copy. Right. I guess we're more of a library. Dependencies, targets, and products. I mean, this page, it's very good, but it's got about 100 definitions on it. A target is the basic building block of an applicative package. Okay. Dependencies managed by Xcode. Versions managed by Xcode. If you ship your source file, Swift packages may be the right choice. Xcode will take care of all the versioning. Okay, creating a package. A target includes any source files in the sources directory. Playing card can be discarded as a library. Now, how do I know whether I'm sources or not? All right. Maybe I need a new project for it. Now, did the tool create this or did they? Okay, so in the sources folder, we've got the thing we're packaging up, and we can have a test folder, which is nice. Okay, so what I'm taking from this, I'm going to need a new project. Swift Run Dealer. XC test manifest. Okay, let's get back to the documentation. Create a target representing a playing card. Okay, a target includes any source files located in the source's target name directory. Okay, let's try Swift. Cool. That's installed. Swift available in here. All right, let's see what we did here. Let's, oops, cancel. Try that again. Okay, so I guess we updated the view a little bit. Content view, I think we changed, yeah, we added the bottom bar. And stack view, we took that out. Okay, so improved the view. Okay, I'm gonna make You have Swift available. See installing. Okay, we invoke the run Swift package. Create a new one. Create an error directory. Must have a manifest. You can create it by using that. It'll create a package directory structure. Like, how does it know? I guess it's going to throw some default stuff in there. Okay, let's... Where are we? Okay. I don't know what to call this. AlgoViz. We'll do Swift package init. Okay. All right, bunch of stuff. Okay. Now, build. I don't see how this is going to do anything at this point, but Swift build. You'd think at some point I would have to put my files in there. Set it. Dependencies is empty, so you wouldn't think there'd be any problem there. Targets. Okay. Something's wrong. Not much there. Well, that seems like it should work. Swift build. Oh, let me get back up to the top. Oh, there it goes. Okay. Okay, that's caught us up. We don't need an executable. Create a new file called this, enter the following code. I don't know what's going to update the package, though. How would it know it needs the other stuff? I don't know. A deep dive may kill me here. Modules, packages, products, dependencies. I guess what I'm missing is, like, once you've created this thing, how do you get it anywhere? Manifest. Go back to getting started. Okay, installed it. We can use the REPL using the package manager. Let's see what this does. Is there an update or something like that? Update. Okay. I guess I want to move some stuff, right? Or at least copy it. Oh, let's see. Where is this? Desktop. Twitch. Hanoi. Okay, here's AlgoViz. Here's towers. Well, I want to open Xcode here, I guess. Let's see if I can just create a new Xcode project there, then update and go with it. New target project. Static library? Algo viz, okay. Okay, what have I done? List. Oh, I put it one level up too high. Okay. Well, there's probably no harm in that. Something's weird. Show and finder is what I meant. Algo viz. Okay, I pulled down package. Is there a refresh? All right, let's see if I can copy some files in and I don't know if I can just do this. Better this way. Counter, run and main through head stack and stack view. I guess I can add those. right. Okay, I have the files. I don't know what happens here. If I just do a build. And I should have some tests too. Let's make a new group for tests. And I don't know, I'm going to have to do some organization. Counter and stack. I need. Okay. Well, that's algo viz tests.swift. I don't want these tests. Where are they? Tower of Hanoi tests. And here. Some approximation of something. Okay. How's this one doing? He's still scanning build tasks. Can I undo that? Because that sure didn't look very good. No such module package description. I don't know, I may be messing things up faster than I'm improving them. Okay, I do have the files I want. And those things seem okay. But I don't know, I feel unit testing bundle tests. Well, I think I'm going to pause it here. I'm going to have to understand how Swift Package Manager works with Xcode a little bit better, I think. Clearly, it knows package. Yeah, we'll stop here. So in summary, I guess we've made progress on several fronts. One of them was we did have a discussion last week about recursion and how to eliminate it and all that good stuff. But this week I've been focused on this visualization approach, and I don't know if it's the ideal approach, but basically you're going to modify things so that you run the algorithm in a separate thread. You're going to have your data structures that are involved in the algorithm will be observable objects with published fields, and they're going to make sure that anything that changes the state runs in the main thread, which means the UI can update the visualization. We've got a component for one of our data structures, a stack view, and also you're going to put a sleep statement somewhere in your algorithm to slow it down. I think we did a second between each step, but that could be controlled as well. But at any rate, I think this gives us a starting point approach for things. I do want to pull out these files into a library of some sort that I can drag from project to project. Maybe each time is going to be a dry run, getting me closer and closer to that. But I think this will put us in good shape for next week. So next week, I want to run Dijkstra's shunting yard algorithm, which is sort of it's not exactly parsing. It's more like convert infix to postfix, and it uses a stack and it uses a queue, or maybe a stream, but one or the other. So I'm anticipating we have to create a stream object using these new rules and attach them together and put the algorithm in and convert expressions to postfix. And maybe we'll tack another stack on the end because you can evaluate postfix pretty easily. So we'll pick up there. So it'll be next Tuesday, 1 to 3 p.m. Eastern time. If you're watching this on YouTube, I'm going to have a delay week in there, so there won't be anything out for the week following this episode, but I'll get it back in shape as we go. All right. Thanks for joining me, and I hope you can catch me another time. Take care. Bye-bye.